Hello everybody. Once again I am here with you for the nearly last point or last but one point of this unit, that is free and forced vibration. And in previous session we have seen what is mean by the sharpness, resonance and sharpness of resonance. Now we are looking today for the phase of resonance means what, and related to that, what exactly meaning to be phase of resonance and how it is to be going to be formed. Now to get exactly the relationship, basically uh, what meaning to be as an phase of resonance part is to be there. For that we have to consider the phase lead to the force of vibration with the reference to the driving force, that is the tan alpha. In the previous session we have seen tan alpha is equal to mu p upon k minus mp square is to be there. This relationship is to be, you have to take into account for the getting the phase relationship is to be there. So this is what the phase angle, that is to be tan of alpha and that, considering this phase for in the force of vibration, with referencing with this particular case or the equation, we are we can find out what is to be as an phase of resonance is to be there. Resonance, we are already aware about that. The it is simply what you can say, if two bodies are there, and if I am vibrating one body, and similar vibrations will be seen in the another body, as it is steady state, that is vibratory motion will be there in the another body which is steady, and which will be, if the another body is going to be vibrated, and that will be similar vibrations will be seen in the another other body is to be there. This is what simple the resonance is to be there. And when it is going to be matching with the natural frequency, the external force is going to be matching with the when the external force is given to be uh, matches with the natural frequency of that body, then it is also forming a resonance is to be there. So related to that forced vibration part, we are looking for the phase of resonance. So that's why we have taken this forced vibration relationship for this case as an our phase of resonance is to be there. This is what the relationship is to be there. So moving forward again, the whatever be the part which is to be tan of alpha is equal to given, in this case tan alpha in simple way, again to be as an given, it is to be as an with the driving force, it is nothing but to be as the resonance point k minus m is equal to p square, and in this case tan of alpha is nothing but to be mu p by m. Here this relationship is to be given by as an याला काय केलं की simply m ने जर समजा divide केलं, so the what will happen exactly, if I divide this throughout equation by right side by m, then we will see the new relationship, and that is nothing but to be given here as an relationship is to be here mu p by m. Here it is to be as a mu p by m divided by k by m minus m p square by m get cancelled and p square is remaining. And at the resonance point we are aware about that k by m is nothing but to be equal to p square, we have seen in the force of vibration also. And in this case when the k by m is equal to p square, this value will become to be 0, and definitely tan of alpha or the phase will be as an infinite. That is infinite in that sense, alpha is nothing but to be pi by 2 is to be there, that is 180 is to be there. And again it means for the p by omega is equal to 1, that is to be as an, where the p by omega is maximum to be as an 1, we have seen at that stage phase, that is the pi phase, that is alpha is equal to pi by 2, that is we have seen infinite, that is to be there. and in that graph we have seen the p by omega is 1 at this stage, where the it is showing you the max value for the resonance is to be there. And that is what the case where the p by omega is equal to 1 at this stage. This is p by omega at this stage. In the previous sessions graph we have seen in the sharpness of resonance, and in that case we have seen p omega versus r response is to be there and resonance is to be there. Here it is to be the case where the phase is going to be concerned at the resonance point, where the p by omega is becoming to be value 1. At that stage the alpha is nothing but to be pi by 2. When the p by omega is greater than 1, for the values, if suppose the values are going to be changing, p by omega is greater than 1, definitely alpha is also going to be greater than pi by 2 is to be there. As far as p by omega is going to be lesser than 1, definitely alpha is nothing but to be less than pi by 2 is to be there. So these are the some values for the different whatever be the values are to be here written, that is to be related with the phase and the resonance part, or the p by omega relationships are to be there. Now in this case again we are looking forward to be as an how it is going to be the graph will be formed along the x-axis a p by omega, and along the y-axis there is a alpha. If suppose I will draw this relationship p by omega and the alpha is along the y-axis, in that case if you will see this relationship is nothing but to be like this figure or the relationship or the diagram. The graph is looks like to be as an like this, where if you look at carefully p by omega is nothing but to be here at this stage is going to be the 1, and at this stage the angle is nothing but to be particularly pi. This is completely value as an pi is to be there, and here this is to be as an pi by 2 is to be there. So at this stage when the p by omega is going to be the 1, the alpha is nothing but to be pi by 2, and this is what the where the particularly it is less than p by omega is less than when, in that case what is going to be the graph variation it is shown, and how it is p by omega is greater than 1, it looks like to be the variation curve 1 and curve 2 is to be there, as it is giving you a different values. What exactly this curve 1 and 2 are representing, that will so we will see. See, in this case, if suppose the shape of the curve will also depends upon the values of the mu. No doubt the external frictional force is supposed to be mu is to be there. When the frictional forces are absent, that is mu is going to be 0. If you look at this case where the first case is we are discussing, that is mu value is going to be 0, and in that case the frictional, that is the external frictional forces are to be 0. At that stage the curve will be ABCDE. The graph will be looks like to be as an ABCDE. If you look at this case where the mu is frictional forces are 0 असतील तर त्या ठिकाणी ABCDE म्हणजे ह्या पद्धतीने ग्राफ होईल. It is ABCDE. Likewise this, when it will happen, when there is no frictional forces are there, that is mu is equal to 0 in that case. And if suppose this case is supposed to be as a now changed value for the values for the larger values, that is to be as an for the larger values of mu, if suppose mu is to be very large, the curve will be similar to curve B. That means to be it is, if you look at this case where the mu is having the larger not smaller, either when 0 असेल, ज्यावेळेस 0 असेल त्यावेळेस आपल्याला माहिती आहे इट इज लुक्स लाईक्स टू बी एज एन ABCDE, ज्यावेळेस 0 आहे त्यावेळेस. पण ज्यावेळेस हे सपोज टू बी तुमची म्यूची व्हॅल्यू जर समजा लार्जर आहे तर त्या केसमध्ये दिस विल बी कर्व, दॅट इज टू बी एज एन 2 कर्व नंबर 2 इज टू बी देअर. Sorry, this is what the curve 2 is to be there. So this is what where the case it is to be like this similar. आणि जर समजा व्हॅल्यूज स्मॉलर असतील तर काय होते बघा, ज्यावेळेस म्यूची व्हॅल्यू स्मॉलर असते त्यावेळेस कर्व विल बी वन इज टू बी देअर. दॅट मीन्स फॉर द स्मॉलर व्हॅल्यूज ऑफ म्यू, म्हणजे तिथं फ्रिक्शनल फोर्स तर आहेच, डॅम्पिंग इज टू बी देअर, बट इट इज व्हेरी स्मॉल. So in that case, what will be the curve, what will be the exactly the relationship or the curve will be seen? The curve will be seen like this one. When the mu is going to be the smaller, this peak is to be a little bit deeper, or max is to be there. So this is what the mu and the relationship with the alpha is to be there in that case, and this is how the relationships are to be going to be work. So what is this phase and phase angle, or the at the resonance is to be there, that we have seen in detail. So still for joining, thanks for joining this session, and be at home and be safe.